You are wondering if moving from full-stack development to MLOps is the right career move. You are likely worried that you are stepping into a black box of AI deployment where latency and costs spiral out of control. The truth is that the real challenge is not learning new tools, but re-architecting your entire mindset for a world where hardware economics dictate your success more than code quality ever did. Let us start by looking at where you are right now. As a full-stack developer, you are comfortable with the rhythm of the web. You build services that handle user requests, and you scale them by adding more standard servers. If traffic spikes, you spin up another virtual machine. If a server fails, you replace it with another identical one. This model works because commodity CPUs are cheap, plentiful, and flexible. You optimize for latency and code modularity. You design microservices that talk to each other over a network. Your biggest enemy is usually a slow database query or a memory leak. Now consider the world of machine learning operations. This is not just a different set of tools. It is a fundamentally different operating system. In MLOps, you are not running on cheap, general-purpose CPUs. You are running on specialized accelerators like graphics processing units or tensor processing units. These chips are incredibly expensive. They are designed to crunch massive numbers of calculations simultaneously, but they are terrible at doing anything else. If you try to run a single prediction on a GPU, the cost of turning that chip on and getting it ready often dwarfs the cost of the actual calculation. This creates a friction point that does not exist in web development. In your current work, if you write inefficient code, you might see a slightly slower response time. In MLOps, inefficient code means you are burning thousands of dollars a month on idle hardware. The economics are inverted. A software engineer optimizes for speed of development and modularity. An MLOps engineer must optimize for hardware utilization and batch throughput. You cannot simply port your web dev patterns to this new environment. Horizontal scaling by adding more servers is often the wrong answer because you run out of GPU memory long before you run out of compute power. Quick resource note: I keep a curated set of Amazon search links in the description for books, gear, and tools relevant to this channel's topics. Some are affiliate links, so I may earn a commission at no extra cost to you. Please consider supporting the channel by using those links if you find something useful. Think about how you currently handle state. In web services, statelessness is a golden rule. You want your servers to be interchangeable so you can swap them out instantly. This allows for rapid scaling and easy recovery. But in machine learning inference, you often need stateful compute sessions. You need to keep the model loaded in memory, ready to accept a stream of data. Context switching becomes a massive performance killer. Every time you warm up a GPU for a new batch of requests, you are paying a hidden tax in time and money. The definition of latency changes completely. It is no longer just about how fast your code runs. It is about how quickly you can get the hardware ready to run your code. This is where many full-stack developers stumble. They try to apply the microservices architecture they love to machine learning models. They want to break a large model into tiny services that talk to each other. But this approach destroys efficiency. Large models need to run as monolithic, compute-heavy graphs to maximize the throughput of the expensive accelerator. Splitting them up introduces network overhead and prevents the hardware from working at its full potential. You end up with a system that is flexible but incredibly expensive to run. The cost of the hardware becomes the primary constraint, not the complexity of your code. There is a deeper layer to this shift that often gets overlooked. It is not just about the hardware itself. It is about the maturity of the organization. Research shows that more than half of organizations still fail to produce a single model, and many require over 90 days to deploy one. This suggests that the barrier is not just technical, it is cultural. Your instinct to build modular, testable components clashes with the need for rigid, compute-optimized pipelines. You have to learn to value stability and throughput over the elegance of your code structure. The transition requires you to master hardware-aware scheduling. You need to understand how to isolate resources so that one noisy neighbor does not slow down your entire training job. You need to orchestrate batch-serving architectures that keep the expensive chips busy. This is a skill set that web development rarely demands. In web dev, you can afford to be flexible. In MLOps, flexibility is a luxury you cannot afford. Every second of idle time on a GPU is money thrown in the trash. So, is this a good long-term career move? The market data suggests yes. We are seeing projected growth in this field through 2025. But the value you bring is not just knowing Python or how to use an orchestration tool. The value you bring is the ability to translate software engineering principles into a hardware-constrained reality. You become the bridge between the abstract world of algorithms and the very physical, expensive world of silicon. You learn to build systems where software efficiency directly dictates the bottom line. This shift is not for everyone. It requires a humility that comes from realizing that your previous best practices might be the wrong ones. You have to abandon the comfort of stateless services and embrace the reality of stateful compute sessions. You have to stop thinking about code as the primary driver of performance and start thinking about the silicon as the ultimate bottleneck. If you can make this mental leap, you will find yourself in a position that is rare and highly valuable. You will be the engineer who understands that in the age of artificial intelligence, the most expensive resource is not the code you write, but the time the hardware spends waiting for it. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.